So in this particular problem, we need to prove the Cramer's rule for solving the system of linear equations using vectors. So let us begin. Let's label these three equations as 1, 2, and 3. So we'll consider the first equation, equation number 1, and multiply each term with the unit vector I cap. This will be simple multiplication, not a cross product. So this will give us. Next, we consider equation number 2 and multiply each terms with the unit vector j cap. So this will be. And then finally, we consider equation number 3 and multiply each terms with the unit vector k cap. So this will give us. So let's label each equation as. So what we'll do in the next step, we are going to add equation number 4 to equation number 5 and to equation number 6. So we'll add all the three equations and this will give us. So if we consider these three terms, so we can take x as the common factor. So this will be x multiplied to a1 I cap plus a2 j cap plus a3 k cap plus. So we'll consider these three terms. So we can take y as the common factor. So this will be multiplied to b1 I cap plus b2 j cap plus b3 k cap plus the three terms. So we'll have z as the common factor. So this will be multiplied to c1 I cap plus c2 j cap plus c3 k cap, which will be equals to d1 I cap plus d2 j cap plus d3 k cap. So this can be written in the vector form as x times a vector plus y times b vector plus z times c vector, and this will be equals to d vector. Let's call it equation number 7. This is the condensed form for all the three system of linear equations. Now what we'll do, we'll take equation number 7 and then dot each of the terms with b cross c. Now this is a dot product, so we'll have to be a little bit careful here. So we have x, the first term, times a vector dotted with b cross c. Then we have the second term, so that will be y times b vector dotted with b cross c. Then the third term will be z times c vector dotted with b cross c, and this will be equals to d vector dotted with b cross c. Now here what will happen, these two terms will go to 0 because we have the scalar triple product here. If two vectors are equals, so here we have b equals and here we have c equals, so that goes to 0, and that leaves us with x times a vector dotted with b cross c, which is equals to d vector dotted with b cross c. So solving for x, we have x equals to d vector dotted with b cross c divided by a vector dotted with b cross c. So this is the first value of x we have obtained. Coming back to equation number 7, now we will take the dot product with c cross a, we'll dot it with each of the terms. So that means the first term will be x a vector dotted with c cross a. Then we have y b vector. So b vector will be dotted with c cross a plus z times c vector, and c vector dotted with c cross a. So this will be equals to d vector dotted with c cross a. So here the first term will go to 0. So this will go to 0, and the third term will go to 0 because we have two vectors that are repeating. So here it's also repeating. So that means when we solve for y, then y is going to give us d vector dot c cross a divided by, so we have b vector dotted with c cross a. Then finally what we'll do, we'll consider equation number 7 and then we take the dot product of each terms with A cross B. So we'll consider equation number 7 and take the dot product with A cross B. So the first term goes to 0 and the second term goes to 0. Now coming to the value of z, so z will be equals to d vector dotted with A cross B whole divided by, so we have c vector dotted with A cross B. Right. So therefore, we have obtained the values of x, we have the value of y, and we have z. And these values establish the Cramer's rule by using vectors, which can be used to solve the system of linear equations.